Hey guys, a quick video on ionic bonding using the crisscross method. This is something we went over in class, but just in case you're studying and forget some stuff, here's some extra details to help you out. So let's say that we are starting with something like hydrogen. We'll start easy. Hydrogen, and let's do oxygen. Okay. Actually, let's change that. Let's do sulfur. So the first step, as always, is we need to take a look at the families of the periodic table. We know that 4 is kind of our dividing line. Everything on this side is going to give up electrons. Give away electrons. Everything on this side is going to take electrons. That's because every atom wants to end up with the key number of 8. So if you're something like phosphorus that has 5 in that outer level, it's a lot easier to gain 3 than it would be to lose 5. It just makes a lot more sense. So something like hydrogen, having 1 to give away, if it gives away something negative, it will become positive. Sulfur, on the other hand, has 6. So in order to get to 8, it needs to gain 2, which means it will be 2 minus. It will be a negative 2 charge. So in order to see how these things bond together, hydrogen and sulfur, we take H, we'll draw a little line here, S, draw a little line. This is really actually pretty easy. You take this, you cross it over here. Take that, you cross it over here. And there's your crisscross. So this becomes hydrogen 2, sulfur 1. We call that hydrogen sulfide because remember, when sulfur, since it is a negative ion, because it's got a negative charge, since it changes, we change its name to sulfide. Okay, so we'd call that hydrogen sulfide. Now, a great way to check your work and make sure you do this, even though this is obviously pretty easy, what you can do is you can say, okay, so we've got 2 hydrogens, and we're multiplying it by a charge of +1. Does that even out the 1 sulfur and its 2 minus charge? So this will end up equaling 2 plus, this will be 2 minus, okay, they cross out, perfect, we did it right. Because remember, every compound wants to be stable. And in order for it to be stable, it needs to be neutral. So if these charges here cross out, that's neutral. If it wasn't neutral, that means it would either be positive or negative still, and if it bumped into something else positive or negative, it would react with it. It would steal electrons, it would form a whole different compound and become something else. So when we're doing this, if we're saying this is the reaction that we're doing here between hydrogen and sulfur, in order to make it a neutral, stable compound, the charges need to cancel each other out. The easiest way to do that is the crisscross method. So let's do another one. Let's try this out. Erase all this. All right, almost there. Well, I guess I'm erasing this now that I erased the C. Okay, so let's try with something like beryllium and something like phosphorus. Okay, so beryllium has 2 electrons in the outer layer. It'll give it away, so that'll be 2 plus. Phosphorus has 5 in the outer layer, so it's going to gain 3, so it'll be 3 minus. So we rewrite things here with the little line, and we do our crisscross. So beryllium 3, phosphorus 2. So we would rewrite that without the lines. Wonderful. Now, to double check that work, we've got 3 berylliums, which are a charge of 2 plus. We've got 2 phosphoruses, which are a charge of 3 minus. So that's 6 plus, and 6 minus. Perfect. They cancel each other out. We did that one correctly. I'll leave you with just a practice problem so that you can fill in on your own. Let's take boron plus fluorine. So you will rewrite it down here. Oops. Let's just erase that and write it neatly. You'll fill in what the charge is, and then you'll do your crisscross method. I hope this was helpful. If you have any questions, obviously feel free to send me an email, and I can help you out more. Thanks.